Okay, so we are solving, what are we solving? We're solving Unit 1 exam. Um, Preparation for Unit 1 exam. This is Chapter 1, Chapter 2. So question 1 said solve the equation PV is equal to QT for Q. Then solve for Q if pressure is 12, volume is 10, temperature is 3. So this is a two-part problem. If PV is equal to Q times T. If we're solving for Q, then we have to undo the T. Right now, it's being multiplied by T, so we divide both sides by T. You can see that T over T reduces down to 1, so Q is equal to PV divided by T. There's our answer. Or you can write it as Q is equal to P times V divided by T. Maybe that's pretty good. And then the second part is find Q if P is 12, volume is 10, and temperature is 3. So to solve for Q, pressure is 12, so that's P is 12, and the volume is 10, and temperature is 3. There we go. So we multiply 12 times 10, which is 120, and that's divided by 3. And 120 divided by 3 is 4. So there's your second answer. Here's the first answer. Here's the second. Alright. Question number 2. I is equal to P times R times T. Solve for R. So to get R by itself, we have to undo the P. It's being multiplied by P, so we divide by T. Also, we want to undo the multiplied by T, so we divide by T. So on this side, we divide by PT, and on this side, we also have to divide by PT. That's called division property of equality. So P over P reduces to 1, and T over T reduces down to 1. So R is equal to I divided by P times T. Or R is equal to I divided by P times T. We don't have to substitute I or P or T with anything, so that's just our final answer. And then on part B, we're asked to solve for A. That's this bit over here. So here's our equation. We can start solving for A by undoing the negative 4x. So I'm going to add 4x to both sides. That's additive inverse. Addition property of equality tells us that if we add 4x to the left, we have to add 4x to the right. This 4a business is simply different. So we have 4x minus 4x, that's 0. 0 plus 3a is 3a. And that's equal to b plus 4c. There's b, there's 4c. They're not like terms, so we just leave it side by side. Finally, to solve for a, we have to undo this multiplied by 3. So divide this by 3, divide this by 3, divide this by 3. So 3 over 3 reduces down to 1, so just 1a. So a is equal to, it's b over 3, or the coefficient of the b is a 1. You don't see it, but there's a 1 there. So maybe it's prettier to write a 1/3 b, and then plus 4/3 x. My answer runs over. Let me try it again. A is equal to 1/3 b plus 4/3 x. Okay, this one fits. There's your A. Alright, some word problems. Next, number 4. Number 4 says, a college student is moving into a campus dormitory. A student rents a moving truck for $19.95 plus 99 cents per mile. Before returning the truck, the student fills the tank with gasoline, which costs $65.32. The total moving cost is $144.67. Your task: write an equation to represent the cost. How many miles did the student drive? So we have to box in this important data, information, etc. boxed it in so you know what you're looking at. Okay, so this is a cost equation. So the first, the guy has to rent a truck, and then he has to pay for costs for the miles. It's 99 cents a mile, multiplied by the amount of miles that he drives. So miles, this is what school call it mileage cost. Okay, and then he has to pay $65 for gasoline, and then that's his total cost right there. So that's how we write our equation. So let's fill in the little bits here. First, the truck, 1995. That's how much she left the truck for. The mileage cost is 99 cents per mile, so it's 0.99 times M. And M is the unknown that represents the amount of miles that the kid drives. And then there's gasoline involved, and that costs $65.32. Then the total cost is $144.67. There we go. So now we have to solve for M, and M would be the amount of mileage that's driven. So we have a constant, here's another constant, and we can add 1295 to 6532, so 19.95 plus 65.32 is equal to, what is that, 19.95 plus 65.32, and that comes out to be 85.27. Okay, so we have 85.27 plus 0.99 M is equal to 144.67. Okay, that's much cleaner. So now to solve for M, we have to undo this bit. So we're going to minus 85.27 to the left and the right. I think that's called, what is that called? Subtraction property of equality. So that becomes 0.99 M, and we have 144.67 minus 85.27, and we have 59.4. And then to solve for M, we have to divide both sides by 0.99. So 99 divided by 99 is just 1 for M. And then we have 59.4 divided by 0.99, and we have 60. So what is the meaning of 60? It means the student drove 60 miles. To get to college. $60 miles to go to college. A perfect distance. Not too far, not too close. Okay, number 5. Greg starts the school year with 32 service hours. During the school year, he earns 8 hours per month. Darren starts the school year with 2 hours and earned 14 hours per month during the school year. So it looks like Greg started out with more service hours, but he only adds 8 hours per month. And Darren started with only 2 hours, but he's added 14 hours per month. So he started with less, but he's adding more. But they want to know when Darren is going to have more service hours than Greg, because Darren started out with less. Anyway, let's write some equations about their hours. So let's write an equation about Greg's hours. So Greg's hours is going to be 32. He starts out with 32, and then every month he adds 8 hours. So there's Greg's inequality. And then let's write Darren's, I said inequality, I meant to say equation. This represents his hours. And then there's Darren. So Darren starts out with 2 hours. Every month he adds 14 hours. So this is Greg's hours. This is Darren's hours. So the question is, what is the question? When will Darren have more service hours? So we're going to write Darren when it's going to have more service hours. That's greater than. And then that's going to be Greg. All right. Well, Darren is 2 plus 14M. M is for the month. And then greater than, and Greg's thing is 32 plus 8M. So now we solve for M, and that's the amount of months that's going to take for Darren to have more hours than Greg. Well, there's 14M on the left and 8M on the right, so why not minus 8M to both sides? We have 2 plus 8 and 9, that's 6. 6M is greater than 32. So to solve for M, we need to undo this 2, so we're going minus 2 to both sides. Then we have 6M is greater than 30. 6 is greater than, divide both sides by 6. We have M is equal to 5. So it means that it takes more than 5 months. For Darren to have more hours than Greg. It takes more than 5 months for Darren to have more hours than Greg. Okay. Well, that took care of page 1. Let's go to page 2 of the practice exam. Okay, number 6. Another word problem. Marissa is trying to lose some weight. So far, she had lost 13 pounds. Her goal is to lose 51 pounds. She's on a calorie counting plan that will allow her to lose 2 pounds per week. What is the minimum number of weeks she must follow her plan before she hits her goal? So let's write an equation for her weight loss. So far she has lost 13 pounds. Now her goal is to reach 51. So she lost 13 already, and she's continuing to lose 2 pounds a week, so that's going to be plus 2 times W. W is the amount of weeks. Every week it's 2 pounds that she's losing. So this is how much pounds she's losing. Now, her goal is to go 51 or more, at least to lose 51 pounds. Is it to lose 51 pounds or more than? Okay, anyway, so greater than equal to, that's her goal. She can reach that, she can go beyond, she can stop, I don't know. So we can solve for the weeks from here. We start out by minus 13 to both sides. And then 13 minus 13 is 0. We have 2W is greater than equal to 51 minus 13. And that's 38. And then to solve for W, we just divide by 2. And then we have W is greater than or equal to 38 divided by 2. And that's going to be 19. So 19 weeks. She will reach her goal in 19 weeks. 19 weeks. And that should be skinny. 51 pounds. That's a lot of weight. Okay, so let's go to number 7. Number 7 said solve the equation for y, justify your solution, explain each step that you use. Okay, so I can see that there's a 2-big multiply with this thing over here, so we might want to do what is called a distributive property. So we have 3y, 2 times negative 4 is negative 8, 2 times 2y is 4y, that's equal to 7 minus y, and that's called distributive property. Alright? And then from here we have 4y, we have 3y, we have 4y, we can add it up. That's 7y minus 8 is equal to 7 minus y. So we're just adding like terms over here, so that's called combining like terms. And then you can see that we have variables on both sides. We should probably move this variable to minus y. So we're going to add y to both sides. And then we have 8y minus 8 is equal to 7. That y goes away. So adding y to both sides was addition property of equality. And then finally, to solve for y, you can undo that negative 8. You can add 8 to both sides. And then we have 8y is equal to 15. Adding 8 to both sides is also called addition property of equality. And then to solve for y, we have to undo that multiply by 8. So we're going to divide by 8. And y is equal to 15 over 8. 15 over 8, and you use your calculator, you get 1.875. So bigger than 1, smaller than 2. If this was money, it's $1.88. Oh, and finally, the last part was division property of equality. There's your answer. Okay, now number 8, 9, and 10, we have to solve for some variable. We divide both sides by negative 3, and negative 3 over negative 3 is 1, we have p. Now we divide by a negative number, so the direction equality, instead of less than, it's going to change to greater than, and that's negative 8 over 3. So graphing it, we can say this is negative 8 over 3, and p is greater than, so all numbers to the right. There we go. To solve for a, we have to undo that 10. We're going to add the 10 to both sides. And then divide through by 7. And we have a is greater than 3. We didn't change the sign because we didn't divide by a negative number. So this is 3, a is greater than 3. It's our set of numbers to the right. Don't fill that in. Oh, yes we do. We fill it in because there's an equal to sign. Totally forgot. Alright. A is greater than or equal to 3. Could be 3, 4, 5, etc. And then what are we doing here? Solve for p. Now we have why don't we minus 9p to both sides? Looks like it might be easier if we minus the 4p, but live dangerously. So here we have 4p minus 9p, that's negative 5p. And then we divide both sides by negative 5. Now we have negative 2 is, now change it to greater than, because we divide by negative 5, and that's p. But we normally put the variable in front, so it's going to be p, which is negative 2 is greater than p, so p is less than negative 2. And when we graph it, we put negative 2 on a number line, it's less than, and we go to the left. And we don't fill it in because it doesn't have equal to. Okay, that was fast. Let us go to the final page. Solving for 11. So to solve for this, we can combine like terms here. There's a 7a, there's a 4a. 7 plus 4 is like 11, so it's 11a minus 1. Greater than or equal to, you distribute the 8, you have 8x plus 12. 8 times 4 is 12. Is it? No, it's not. 8 times 4 is 32. Silly. Then there's the plus 2a. Okay, so now what? Oh, we can combine like terms here. There's an ax. Oh, what? What? That's weird. That's weird. That's an x. That should be an a. Alright, here we go. Let's fix it. Okay, better check this. 7 minus 7 plus 4, that's 11 minus 1. 8 times a, 8 times 4, 32 plus the 2a. Okay, we're legit. We can combine like terms, that's like 10a. That's 32. Okay, now we can get the a's to one side. We have minus 10a to both sides. We have a minus 1 is greater than or equal to 32. Then we can add 1 to both sides. We have a is greater than or equal to 33. Then if this is 33 on your number line, a is all numbers bigger than or equal to 33. Alright. Solve and graph the solution if possible. Okay, so the absolute value business has to be by itself, which it is. It's greater than or equal to 5. So normally when we have absolute value, we can expect two solutions. So what we do right now is that we're going to write two inequalities, one normal and one weird. So what is the inside here? Y minus 3 greater than or equal to 5. Very normal, just the way you see it. The weird part, y minus 3 less than or equal to negative 5. You can see, switch places. And then we solve for y, we add 3 to both sides, y is greater than or equal to 8. Over here we add 3 to both sides, where y is less than or equal to negative 2. So solving it, negative 2 is smaller, we put it to the left. 8 is bigger, we put it to the right. Y is greater than or equal to 8, fill it in to the right. Less than or equal to negative 2. There we go. That's our solution. Yeah, number 13. So in number 13, we have to get the absolute value thing by itself. It's multiplied by 3, it's minus 5. We undo that one first. I'm going to add 5 to both sides. Remember, there's an inequality. So we have 27 here. We have less than 3 times the absolute value of r plus 2. That 5 is gone. Now, this 3, you should not distribute it. You should divide it by 3. Now we have 9 is less than absolute value of r plus 2. So maybe this is a little unconventional, so maybe we should rewrite it like this. R plus 2, absolute value of r plus 2 is going to be greater than 9. Right? Switch places. Okay, now we can write two inequalities. One normal and one weird. R plus 2 is greater than 9. R plus 2 is less than negative 9. Get a minus 2 to both sides. R is greater than 7. Minus 2 to both sides. R is less than negative 11. Okay, let's graph it. It's negative 11. This is 7. R is greater than 7 to the right, less than negative 11 to the left. And we don't fill it in. Okay, the final problem. We need to get the absolute value business by itself. We have to undo that negative 7. So I'm going to divide by negative 7. That's 1. We have the absolute value of m plus 1 is less than, no, it changed places, greater than equal to negative 3. There we go. So it looks like from here we would set two inequalities, one normal, one weird, except you may notice that this is a negative number and this is greater than equal to. So this is already a positive number, and all positive numbers are going to be greater than a negative number. So m is all real numbers, because absolute value is a positive number. So it is always greater than or equal to a negative number, such as -3. Any positive number is going to be greater than -3. So we can say that M is a member of all real numbers. Oops. And that concludes Unit 1 review. Okay, so watch this and then take your Unit 1 exam. If I hope it helps. I hope you understand it. You might want to watch it a couple of times before you take your exam. Okay, all right, bye-bye.